The relevant codes include the National Electrical Code, NEC, Article 225, outside branch circuits and feeders, Section 225.25, vertical clearance, and the National Electrical Safety Code, NESC, Rule 233, underground electric supply and communications lines. NEC 225.25 states that for a door conductors not over 600 volts nominal, the vertical clearance above the ground or other surfaces shall not be less than 10 feet, except over areas or driveways accessible to vehicles subject to the provisions of 250.5 B, 2 or C, where the vertical clearance shall not be less than 18 feet. NESC Rule 233 requires that underground electric supply lines and communications lines be installed with a minimum vertical clearance of 18 feet above finished grade for service drops and 10 feet above the ground or other surfaces for primary distribution lines. The NEC allows for a vertical clearance of 10 feet for outdoor conductors not over 600 volts, which implies that a site light may not be in violation of the NEC. However, the power company is likely referencing the NESC, which requires an 18 feet vertical clearance for service drops. Since the site light is a service drop, it would be in violation of the NESC if it is less than 18 feet below the power company lines. Based on this information, it is likely that the site light is in violation of the NESC. To avoid any potential safety hazards or legal issues, it is recommended that the pole be moved to comply with the NESC requirement of 18 feet vertical clearance for service drops. The NEC and NESC are two distinct codes that address electrical safety, but they have different scopes and applications. The NEC primarily focuses on the safe installation of electrical wiring and equipment within buildings and structures, while the NESC covers the safe installation and maintenance of electrical supply and communication lines, including those owned and operated by power companies. Article 225 of the NEC provides requirements for outside branch circuits and feeders, which include conductors that extend from a building or structure to supply power to outdoor equipment, such as site lights. Section 225.25 specifically addresses vertical clearances for these conductors. The NEC vertical clearance requirements are based on the voltage of the conductors and the type of area they pass over. For conductors not exceeding 600 volts, a minimum clearance of 10 feet is generally required above ground or other surfaces. However, this clearance increases to 18 feet over areas or driveways accessible to vehicles. This higher clearance is intended to prevent contact with vehicles or equipment that may pass underneath the conductors. The NESC, on the other hand, sets clearance requirements for electrical supply and communication lines, including those owned and operated by power companies. Rule 233 of the NESC addresses clearances for overhead lines. The NESC's clearance requirements are based on the voltage of the lines, the type of area they pass over, and the presence of other objects or structures. For service drops, which are the conductors that connect the power company's lines to a customer's building or structure, the NESC requires a minimum vertical clearance of 18 feet above finished grade. This higher clearance is intended to ensure that the service drop is safely out of reach of people and equipment. In this case, the power company is likely referencing the NESC's vertical clearance requirement for service drops. Since the site light is connected to the power company's lines and is considered a service drop, it must comply with the NESC's 18 feet clearance requirement. If the site light is located less than 18 feet below the power company's lines, it would be in violation of the NESC. It is important to note that the NESC is generally considered to be the more stringent code when it comes to clearances for electrical supply and communication lines. This is because the NESC is specifically designed to protect the public from the hazards associated with these lines. Therefore, even if a site light meets the NEC vertical clearance requirements, it may still be in violation of the NESC if it does not meet the NESC's more stringent requirements. To determine whether a site light is in violation of the NESC, it is necessary to measure the vertical clearance between the site light and the power company's lines. The measurement should be taken at the point where the clearance is the smallest. If the clearance is less than 18 feet, the site light is in violation of the NESC and must be moved to comply with the code. Firstly, review the specific requirements of NEC Article 225 and NESC Rule 233. Secondly, measure the actual vertical clearance between the site light and the power company lines at the closest point. Thirdly, compare the measured clearance to the required clearances in both codes. Fourthly, if the site light does not meet the NESC requirements, it is necessary to relocate it. Fifthly, ensure the new location complies with all applicable codes and regulations. Sixthly, consult with a qualified electrical engineer or inspector for further guidance and verification. To ensure compliance, consider these additional factors. Firstly, conductor sag. The vertical clearance can change with temperature due to conductor sag. Secondly, future grading changes. Ensure the final grade will not reduce the vertical clearance below the minimum required. Thirdly, local amendments. Local jurisdictions may have additional requirements or amendments to the NEC or NESC. Fourthly, documentation. Maintain records of the installation, measurements, and any corrective actions taken. Fifthly, communication. Maintain clear communication with the power company and local electrical inspector throughout the process. The NEC, specifically Article 225, focuses on outside branch circuits and feeders. This article covers the requirements for electrical wiring installed outside of buildings, including conductors, equipment, and raceways. Section 225.25 specifically addresses the vertical clearance of these conductors above ground or other surfaces. The NEC clearance requirements vary depending on the voltage of the conductors and the type of area they pass over. For conductors not exceeding 600 volts, a minimum clearance of 10 feet is generally required above ground or other surfaces. However, this clearance increases to 12 feet over residential property and driveways, and to 18 feet over public streets, alleys, roads, and driveways subject to truck traffic. The NEC also provides exceptions to these clearance requirements in certain situations. For example, the clearance may be reduced to 8 feet over residential property and driveways if the conductors are installed on the load side of a service point and are supported by a messenger wire. The NESC, on the other hand, sets clearance requirements for electrical supply and communication lines, including those owned and operated by power companies. Rule 233 of the NESC addresses clearances for overhead lines. The NESC's clearance requirements are based on the voltage of the lines, the type of area they pass over, and the presence of other objects or structures. For service drops, which are the conductors that connect the power company's lines to a customer's building or structure, the NESC requires a minimum vertical clearance of 18 feet above finished grade. The NESC also provides clearance requirements for other types of overhead lines, such as primary distribution lines and transmission lines. These requirements vary depending on the voltage of the lines and the type of area they pass over. In addition to vertical clearances, the NESC also sets requirements for horizontal clearances between overhead lines and buildings, structures, and other objects. These clearances are intended to prevent contact between the lines and these objects, which could result in electrical shock or fire. The NEC and NESC are both important codes that address electrical safety. However, they have different scopes and applications. The NEC primarily focuses on the safe installation of electrical wiring and equipment within buildings and structures, while the NESC covers the safe installation and maintenance of electrical supply and communication lines. In cases where there is a conflict between the NEC and NESC, the NESC generally takes precedence. This is because the NESC is specifically designed to protect the public from the hazards associated with electrical supply and communication lines. To ensure compliance with both the NEC and NESC, it is important to consult with a qualified electrical engineer or inspector. These professionals can help to determine which code applies to a particular situation and can provide guidance on how to meet the requirements of both codes. The National Electrical Safety Code, or NESC, is a comprehensive set of standards for the design, construction, operation, and maintenance of electrical power and communication systems. It's published by the Institute of Electrical and Electronics Engineers, or IEE, and is widely adopted by utilities and regulatory bodies in the United States and other countries. The NESC aims to safeguard persons from electrical hazards associated with these systems. Several key sections of the NESC are relevant to this kind of situation, and they include Rule 232, which covers vertical clearances of wires, conductors, and cables above ground, roadways, water, and other surfaces. Rule 233 deals with horizontal clearances of wires, conductors, and cables from buildings, structures, and other objects. Rule 234 provides requirements for clearances between wires, conductors, and cables on the same or different supporting structures. The NESC classifies areas based on the level of human activity and the potential for contact with electrical facilities. These classifications include urban, rural, and limited access areas. Clearances are generally higher in urban areas where there is greater potential for human contact. The NESC specifies different voltage levels for electrical systems, such as low voltage, high voltage, and extra high voltage. Clearances are generally higher for higher voltage systems due to the increased risk of electrical hazards. The NESC addresses the effects of sag and swing on conductor clearances. Sag refers to the vertical displacement of a conductor due to its weight, while swing refers to the horizontal movement of a conductor due to wind or ice loading. Clearances must be maintained under these conditions. The NESC provides specific requirements for clearances around buildings and other structures. These clearances are intended to prevent contact between electrical facilities and buildings, which could result in electrical shock or fire. The NESC also addresses clearances over roadways and other areas where vehicles may pass. These clearances are intended to prevent contact between electrical facilities and vehicles, which could result in electrical shock or damage to equipment. The NESC includes requirements for grounding and bonding of electrical systems. Grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metallic parts of a system are at the same electrical potential. These measures help to reduce the risk of electrical shock. The NESC requires regular inspections and maintenance of electrical systems to ensure that they are in safe operating condition. Inspections should be performed by qualified personnel and should include a review of clearances, grounding, and other safety-related aspects of the system. The NESC is a complex and comprehensive set of standards. It is essential to consult with qualified professionals when designing, constructing, operating, or maintaining electrical power and communication systems to ensure compliance with the NESC and to protect the safety of persons. To understand how the NEC and NESC interact with local regulations, consider this. Firstly, local jurisdictions often adopt and enforce either the NEC or the NESC, or both. It is important to determine which code is applicable in a specific location. Secondly, local amendments to the NEC or NESC may exist. These amendments can add, modify, or delete requirements in the base code. Thirdly, local permitting and inspection processes ensure compliance with applicable codes and regulations. These processes may involve submitting plans, obtaining permits, and undergoing inspections by local authorities. Fourthly, utility companies often have their own requirements for electrical installations that connect to their grid. These requirements may be in addition to or more stringent than the NEC or NESC. Fifthly, licensed electrical contractors are responsible for ensuring that electrical installations comply with all applicable codes and regulations. They should be knowledgeable about the NEC, NESC, and local requirements. To navigate the complexities of electrical codes and ensure compliance, firstly, consult with a qualified electrical engineer or inspector. Secondly, obtain copies of the applicable codes and regulations. Thirdly, attend training courses and seminars on electrical codes. Fourthly, stay up to date on the latest code changes and interpretations. Fifthly, maintain accurate records of electrical installations and inspections. The purpose of the NEC is to establish a minimum standard for electrical safety, but it does not cover all aspects of electrical installations. The NESC, on the other hand, is a more comprehensive standard that covers the design, construction, operation, and maintenance of electrical power and communication systems. In cases where there is a conflict between the NEC and NESC, the NESC generally takes precedence. This is because the NESC is specifically designed to protect the public from the hazards associated with electrical power and communication systems. To ensure compliance with both the NEC and NESC, it is important to consult with a qualified electrical engineer or inspector. These professionals can help to determine which code applies to a particular situation and can provide guidance on how to meet the requirements of both codes. Furthermore, the local utility company should be consulted to ensure compliance with their requirements. Utility companies often have their own requirements for electrical installations that connect to their grid. These requirements may be in addition to or more stringent than the NESC or NESC. It is important to be aware of these requirements and to ensure that the electrical installation complies with them. By following these steps, you can help to ensure that electrical installations are safe and compliant with all applicable codes and regulations. The NESC addresses numerous specific scenarios related to vertical clearances, including firstly, clearances over roadways, specifying different types for varying types of vehicles. Secondly, clearances over bodies of water, accounting for potential boating activities. Thirdly, clearances over railroad tracks, considering the height of trains and workers. Fourthly, clearances above buildings and structures, ensuring safety for occupants and maintenance personnel. Fifthly, clearances in areas accessible to pedestrians, minimizing the risk of accidental contact. Sixthly, clearances from trees and vegetation, preventing interference with power lines. Seventhly, clearances from communication lines, avoiding electrical hazards and signal interference. Eighthly, clearances from other objects, such as signs, antennas, and recreational equipment. The NESC also provides detailed requirements for measuring clearances, including firstly, using calibrated instruments, such as measuring tapes or laser rangefinders. Secondly, accounting for conductor sag, which varies with temperature and load. Thirdly, considering the effects of wind and ice, which can cause conductors to swing or droop. Fourthly, verifying clearances under worst-case conditions, such as maximum sag and swing. Fifthly, documenting measurements accurately and completely. The NESC is a living document that is updated periodically to reflect changes in technology and industry practices. It is important to stay current with the latest edition of the NESC to ensure compliance. The IEE also publishes interpretations of the NESC, which provide guidance on how to apply the code in specific situations. These interpretations can be helpful in resolving ambiguities or disagreements. In addition to the NESC, many states and local jurisdictions have their own electrical codes and regulations. These codes and regulations may be more stringent than the NESC. It is important to be familiar with the applicable codes and regulations in the jurisdiction where the electrical installation is located. The NESC is a valuable resource for electrical engineers, contractors, and utility personnel. It provides a comprehensive set of standards for ensuring the safety and reliability of electrical power and communication systems. To effectively interpret and apply NESC Rule 233, consider these aspects. Firstly, understand the scope of Rule 233. This rule specifically addresses clearances between overhead electrical lines and various objects, such as buildings, signs, and other structures. Secondly, identify the voltage level of the electrical lines. Clearances are dependent on the voltage carried by the conductors. Higher voltages require greater clearances to ensure safety. Thirdly, determine the type of object near the electrical lines. Different objects, such as buildings, signs, or swimming pools, have different clearance requirements. Fourthly, consult the appropriate table or figure in the NESC. The NESC provides tables and figures that specify the minimum required clearances for different voltage levels and object types. Fifthly, consider the effects of conductor sag and swing. Conductor sag is the vertical drop of a conductor between two supports, while conductor swing is the horizontal movement of a conductor due to wind or ice. These factors can reduce clearances and must be taken into account. Sixthly, account for any applicable local codes or regulations. Local jurisdictions may have additional clearance requirements that are more stringent than the NESC. Seventhly, document all clearance measurements and calculations. Accurate documentation is essential for demonstrating compliance with the NESC and for resolving any potential disputes. Eighthly, consult with a qualified electrical engineer or inspector. If you are unsure about any aspect of Rule 233, it is best to seek expert advice. To ensure accurate and consistent application of the NESC, consider these additional practices. Firstly, establish a consistent interpretation of the NESC within the organization. This can be achieved by developing internal guidelines and providing training to employees. Secondly, use standardized forms and checklists for documenting clearance measurements and calculations. This helps to ensure that all necessary information is collected and that the calculations are performed correctly. Thirdly, conduct regular audits of electrical installations to verify compliance with the NESC. This can help to identify and correct any potential violations before they cause an accident. Fourthly, participate in industry forums and technical committees to stay up to date on the latest developments in the NESC and electrical safety practices. This can help to improve the organization's understanding of the NESC and to identify opportunities for improvement. By following these practices, the organization can improve its compliance with the NESC and reduce the risk of electrical accidents. Always remember that electrical safety is a shared responsibility. Electrical workers, employers, and the public all have a role to play in preventing electrical accident. By working together, we can create a safer environment for everyone.